All right, in this video, we are going to do problem 7.72 from our textbook, Women at Work. It says, in the article, Job Mobility and Wage Growth, A. Light examined data on employment and answered questions regarding why workers separate from their employers. According to the article, the standard deviation of the length of time that women with one job are employed during the first 8 years of their career is 92 weeks. Length of time employed during the first 8 years of career is a left skewed variable. For that variable, do the following tasks. A, determine the sampling distribution of the sample mean for simple random samples of 50 women with one job. Okay, so let's go ahead and do that one. I need to write down the standard deviation, and that is 92 weeks. They do not give us what the mean is. Okay. At least in part A, that doesn't matter because they're just asking for the sampling distribution, the sample mean, for simple random samples of 50 women with one job. Okay. I guess it kind of will matter there. All right. So we know that the sample sizes are 50, right? And then they want to know the sampling distribution of the sample mean. Well, we know that from what we studied before in sections 7.1 and, well, I guess it's especially 7.2, that whatever the population mean is, that's what the mean of the sample means is going to be. They don't give that to us at all here, right? So we're just going to have to go with whatever this symbol is, okay? Whatever that is, we don't know at this point. So we're just going to keep this as mu during this problem. All right, the standard deviation we can find, right, of the sample means because we know that that is population standard deviation divided by the square root of the sample size. So that is going to be 92 over the square root of 50. And let's see what that comes out to be to a couple of decimal places at least. So 92 divided by the square root of 50. So I get 13.01 to 2 decimal places. Okay. So that's as good as we can do on that part. All right, it says part B, obtain the probability that the sampling error made in estimating the mean length of time employed by all women with one job by that of a random sample of 50 such women will be at most 20 weeks. Okay. All right. So what they're asking us to do, right? Is to find the probability that if we take a random sample of size 50, right, we want to know what's the probability that will be within the population mean minus 20. And less than or equal to the population mean plus 20. Okay. All right, so now you may say, well, how are you supposed to do that? Because I don't know what mu is, right? And but remember, that's kind of in practice really more like what will be happening in the real world. You won't really know what this is, right? Because of the fact that, when you do that, if you already knew the population mean, then what's the point of taking a sample? Okay. All right. So we are just going to proceed like we did before. Okay. And you'll see that actually we don't really need to know exactly what that is, right, when we go to do this. All right. So here, whatever this distribution is, we know that it's approximately normal, right? They do tell us that this distribution is left skewed, right? But because the population, the sample size is greater than 30, right? That's large enough in our judgment. So we know that the sampling distribution, the sample mean, is approximately normal. So that's good enough, right? And what we're doing is finding the probability that, or percentage, however you want to say it, that the sample mean is in between mu minus 20 and mu plus 20, right? And so we know to do that, we calculate the area of that region right there. And we know to calculate the area of that region, we would use the z-score, right? Z equals x minus mu over sigma. Here we are talking about the sampling distribution and the sample mean, right? So in order to avoid confusion, we should mark those, right, with the proper notation here, because we do have a sigma and this other one, right? So, okay, and so now here, I'm going to try and find the z-score of mu minus 20. And again, I don't know what mu is exactly, right? But that's what I'm going to be finding the z-score of. So I'm going to plug that in right here, mu minus 20. So that goes in for x bar. And then mu sub x, again, we know from the sampling stuff we talked about, the sampling distribution of the sample mean, that is equal to mu, right? Again, we don't know what mu is, right? But we can put that symbol right here. We do know that the standard deviation of the sample means is 13.01, right? Okay. All right, and so you can see something really nice happens, and that is that I have mu here, and here I have minus mu, right? And so by just a little algebra, those cancel each other out, right? In other words, here I have 1, here I'm taking away 1, so how many mu's do I have? I have 0 mu's, and I still have this minus 20 over here. All right, so that is very, very nice, in that now that cancels out these things here. And so what that means is I don't really need to know what the population mean is, okay? All right, so I'm going to make this calculation, and I get minus 1.54 to 2 decimal places. Okay. All right. All right, so next up, I'm going to go to the table and look up minus 1.54. Table 2. All right, and so table 2 will give me this area to the left when I go look that up. So minus 154. So I get that. So that area is 0.0618. Okay. All right. So that's what I get. So I know that the area to the left of minus 1.54 is 0.0618. I also know that it's equal to this area over here that I do not want. Okay. Not only that, I know it's equal to this area right here as well. Right, this part over here to the right. And I know the total area, right, underneath this curve is equal to 1. So what that means is that I can take 1, the total area under the curve, and subtract out 2 times 0.0618, y2. Well, because I'm taking away this piece right here and this piece right here, which I know are equal to each other, right, because of the symmetry of the normal distribution, right? If I cut this in half, right, I will get And because this is 20 above the mean and 20 below the mean, and the mean is right in the middle, right, they would have opposite z-scores right here. All right, so you can go ahead and take the z-score of mu plus 20. It's going to give you 1.54, and you could look that up and subtract those, but to me it's just easier to do it this way. Okay, so I get 1 minus 2 times 0.0618. So I'm just punching that into the calculator, and I get an answer of 0.8764. Okay. All right. Let's see what else they wanted here. And that's it. They didn't really ask us to interpret that at all, right? What's the probability that the sampling error made in estimating the mean length of time employed by a simple random sample of 50 will be at most 20 weeks? Well, that probability, right, will be this number right here, 0.8764. So there's about an 87.64% chance that if we use a sample mean of size, or a sample of size 50, right, that it will be within 20, right, of the actual population mean. Okay.